Alrighty, so as we promised, we would be right back, and we are. Getting some of these cables here out of the way. We can go back and get some of. Alright, so bring the camera up so we can make this thing focus a little bit. There we go. Alright, so we're actually going to start by taking the top off of this, then go to the next stage. So actually, before we do that, since we know that we're going to be doing 110 instead of 220, we're actually going to start one step before that, which is looking at the modules themselves. We're going to make sure that the switches are all preset for 110. Some of these will be set at 220, some of them will be set at 110 based on whoever is putting them together at the factory. All right, so this one's already got a loose screw in it, so chances are, yep, it's already slightly on the stripped side. That's all right. Take the screws out. We'll show you one of a couple ways to fix that issue too. Yeah, unfortunately, quality control, whenever they go to put some of this stuff together, just isn't what it should be. Alright, so that in mind, pop that security tape. Unplug, if I can speak, unplug the fan. Alright. And we're going to take a brief look on the inside here. You're going to see that this looks a whole lot different. You know, I pay, a little bit more for the units that I buy, whether it be the 50 amp modules or like these are the 40s instead of the 30s, which, I've still got some 30s I'm going to be using up for small applications, but honestly, guys, I think I'm going to be utilizing a lot more of the 40 amp modules, and part of it has to do with quality. There's just a lot more quality involved in the overall making of these. They've only got one thing that I don't really care for, but as time goes on, that may change. But anyhow, moving along, I just wanted to kind of touch base with you guys and show you that, here you've got, your, on the input side, you've got your first capacitor here as far as for noise suppression. You've got your incoming AC transformer. Now, on a lot of the 30 amp modules, and that's where you don't get this very often, they've actually got capacitors on the other side before it actually makes it to the rectifier bridge itself. So it's actually kind of nice to actually do that. The boards are a little bit healthier. Some of the ones, especially when you go into the 50 amp modules from the China build, they're usually full of rust, which I think I've done some videos in the past on that as well, and we may go back and touch base on that again at a later date when we get a little more caught up in free time. Now, the only thing on these that I don't really care for, there again, since we're running them at 14 volts, is these three caps here. The only reason why is because of the fact that they are rated at 16 volts, but they do hold. So, they're fine. But instead of 2200 or 3300, they actually put in 4700 UF caps here in this place. Now, some people, and depending on the application, I will pull these out from time to time and move these up to 25 volts if I'm making major modifications to the power supply unit itself. Um, not only bring the voltage up, but I'll also bring the capacitance. Since these are 47, I would actually probably jump up to the next size, which would be a 6800. Reason being is because the height would not exceed, the tallest component in the circuit. So it's another way to give yourself just a little more bang for the buck if you want to actually do that. But now on this particular setup, we're actually not going to do that. What we are going to do is we're going to pull the board and make some slight changes, and we'll go through that as well. And I'll show you some of the can do's, probably shouldn't, and what have you in regards to that, based on the application. So let's go ahead and take care of one other little glitch, which now then I noticed that the screw holes in these, they're not necessarily completely wallered out, but they're not what they should be. So if I can find the other tool that I'm looking for, here we go. All right, there's two different ways of doing the same exact thing. And that is, you can use a precision tool and a precision punch, and actually take where these are actually pushed through. You can actually take and give it a small tap, is what you can do basically, and push in or dimple it. You're not trying to close it off, you just want to dimple it. In this particular case, I'm actually going to use an automatic center punch. This is made by General. They've actually got a better version of this one that's made by Starrett that I really love, but it's about 60 bucks. Unfortunately, somebody broke my really good one. The reason why I mentioned Starrett, if you're doing tons of these, and tons of projects around the house, the Starrett is going to run you about 60 bucks, but it's adjustable. You can actually adjust the physical pressure on this. On some of the Generals, you can also do that as well, which this one, you actually can adjust it by unscrewing the top to a certain degree, and that'll decrease the amount of pressure on the tip itself. So that's what we're actually going to do, is we're actually going to go in at an angle, and we're going to put a small dimple next to where those are going to be at. And that dimple will ensure that the screw itself will hold in place. So if you get one of these and the screws are stripped from the factory, surprise, surprise, now when we go to put it back together, what that's going to do is that's actually going to put pressure on the screw and keep it nice and tight. What we got in there? Ah, Anthony, I see you're back. Glad to see that. Like I said, I think this is going to be kind of educational for you. Now, the other thing too that I've actually been really pleased with on these modules is the fact that they actually use heatsink compound. They don't seem to wimp out like some of the others do. But in order to go ahead and pull this, the only thing I really don't like doing is, and I understand part of the method to the madness, but I still don't like it, is on the label here for the side, you either have to peel it off or you have to dimple it in order to take that clamp off. Probably the worst part about it. All right, so now that we've got that done, it seems like every manufacturer is a little different on how they do this too, as far as screws, screw placements. Most of these are still approximately the same, but just for an example like this one here, for whatever reason, they don't put screws in the back. I have no idea why. All right, so now that we've got those loose, I'm gonna go ahead and slide this forward just a little bit. Now that we've got, go ahead and move this forward just a little bit. Give it a slight tilt. Gently pry on the case. Take the unit out itself. Give it a slight tilt. Gently pry on the case. Take the unit out itself. All right, so now that we've got this removed, now it's an age-old question, you know, chicken or the egg, egg and the chicken. Ha ha ha. If Charles, if you're watching, question, you know, chicken or the egg, egg and the chicken. Ha ha ha. If Charles, if you're watching. Back here, they don't put any heatsink compound. Generally, if I've got these apart, there's going to be heatsink compound. Back here, they don't put any heatsink compound. Generally, if I've got these apart, compound go back on the back side of these. It just helps to reduce that much more heat and give you a little bit more heat transfer in the long run. So now that we've done that, we're going to go through here, and one of the things that I wanted to note, desoldering tool heat up. All right, now based on the configuration and what you're actually doing to these, I've seen a lot of people where they will take the fuse itself either out and run a jumper, or across the back they'll run a jumper across the fuse itself. That's kind of a good idea and it's kind of a bad idea. And the reason why is because obviously a fuse is in there for a reason. Now the other thing is, in this particular case, they've got two of them versus like the 30 amp, which only has one. They have these two resettable fuses. That's the reason why I don't bother to ever strap anything there. These are actually for what they call the inrush current, and there again, I've seen people take these out, strap them. You know, they're trying to squeeze every last morsel of amperage out of every module. Folks, if you're trying to do that, chances are you need to add one more. If you need that little extra out of every one of them, you know, those parts are obviously in there for a reason. So, you know, think about that, you know, next time you go back to do modifications. Now it does have a small filter cap right here as well, as far as from your ground over to the case ground, or over to the case ground. There's actually just one there. There's actually another place for a secondary, so that's something else that can be added, you know, at a later date, or if you prefer to. In this particular case, since we've already got it apart, probably not a bad idea to go ahead and just add one more. Another modification that I've seen people do is right here. I'll try to hold it up here to the camera. Okay, which in this case we've got 1, 2, 3, 4. We've got 4 bars coming across here off of our toroidal transformer, going into service, you know, our current draw on the negative side. Now, this is where I have seen, and I've done this many times myself, to go ahead and help draw more current off of the DC side of it. Now I have taken another wire, whether it be 14, 16, 18, any other size. You can actually run you another jumper wire across this in order to go ahead and gain just a little bit more current, or jumper wire across this in order to go ahead and gain just a little bit more current as far as off the unit itself. So it's a simple modification that can be done. What we're actually mainly going to be focused on today, as far as the modification that we're going to be doing, is right here. I'm actually going to be pulling this VR adjustment out. These modules here that I buy typically do go up to 15 volts on a common basis, and since we're looking at approximately 14.8 for our customer, what we're actually going to do is we're going to pull this out. This is actually going to be replaced with a 10 turn. I'm doing that for two reasons. Number one, so that I can dial these modules down exactly where I want them, for number one. Number two, because of the fact that I know that these are going to get shipped directly to my customer. So even whenever I go ahead and I put a sealer on the potentiometer, I know for a fact that whenever he gets them, they're not going to move. Reason why is because he's actually going to do a change out on the unit itself, and if need be, if he gets concerned, I told him that we can actually sit down and do a FaceTime, or go on Facebook itself and set things up, and we can shoot a live video, and I'll walk him through on the installation of the first one. After you do that, the rest of it's easy. So he's actually just doing a small replacement, and it's going to save him a lot of money because of the cost of shipping to go from one side of the country to where I'm at. So anyways, let's get started. Like I said, I've already got the parts pulled, and like I said, whenever we get it all back together, that's the other thing too that we're going to do. We're going to open this up. We're actually going to, like I said, preset and test this. I've actually got 3 of them, so we're going to do 3 of them exactly the same. So just want to go through here, like I said, touch base, kind of give you a little bit of info as far as on some of the basics. Now, one of the things that we are going to do, since we do have the location here that we can do it, we're going to look and see what they've used here, which I think is a .001. We're also going to go ahead. We're going to go ahead and install the secondary one right here on the board itself for a noise suppression. Why? Because it's an economical part, and we have it already apart. So let's get started, guys. Go from there. There we go. All right. All right. What I'm doing right now is I'm actually bending the legs just a little bit to come a little bit closer to the original locations. And granted, they'll flex a little bit as far as to get back in there where we need it, but instead of straight, get this thing to focus again. You'll see that I've actually offset the legs just a little bit, 2 of them to the back, 1 of them to the front. That way we can go back and plug it directly into the unit itself. See how that goes. All right, so one of the things that I see here that I want to actually change is we're actually going to change the direction of it. The reason why is because the fact that I actually want the potentiometer closer to the bridge that we actually pick up our power off of. And the reason why is because whenever I go to put a small amount of adhesive on it, it has something to help stabilize it. Okay. Now there again, since we've already got it apart, we're also going to take I'm going to pretend some of our leftover 22 gauge wire. And it's unbelievable how many amps you can actually draw through a 22 gauge wire, especially when you're talking an inch. Like I said, it's just unbelievable. So what we're actually going to do is we're going to go all the way to the other end of the board. We're going to pick up on the other side of it. We're going to run that small little 22 gauge wire across there where those four bridge jumpers that I showed you are. We're actually going to run one small jumper across that. There again for a little bit more stabilization on current draw. We're also going to check and make sure that all of our solder joints and everything are really good and our pads are nice and heavy. Why? Because this is where we're going to be hooking in for our DC current. Now the other thing that I'd made mention, I'm actually going to unsolder the holes that are shut. Why? Because we're going to go ahead and add one extra filter. And where they've got that hole soldered shut, since I didn't clean my nozzle good before we started. All right. And we're going to go ahead and add that one extra filter there. Any questions, Anthony? I think you're the only one left there in there, big guy. I won't know if you don't ask. And I don't always remember to say. All right, and the installation is essentially the same. You know, you're going to get it lined up. All right, and the installation is essentially the same. You know, you're going to get it lined up. There's actually cutouts on the sides of these to go past those dimples that are in the case. Once you got it just right, it'll just fall into place. I'm going to start by getting these sunk down in there. Now, I know it's got a place for two more, and we actually are going to try to put two more screws in there. So I'm going to go over here to my used screw bin. Since it just so happens that this one uses a number 3mm. I'm going to go ahead and install the missing screws. Line up that clamp block, make sure that it's a little bit more square, and we've got even pressure going across the transistors that holds it up to the heat sink. I know whenever they install these from the factory, they don't get quite that technical, but you know, they're also doing piece rate, where we're not concerned about piece rate. We're worried about quality rate. Some people will tell you that it doesn't make a difference. Well, I beg to differ that. Why would you not want to clamp them exactly the same? These are main, vital, important parts in any unit. You can either tighten these up by hand, which I really do recommend for most people, especially if you've got a very high torque drill gun. You can actually strip those out, and then you're kind of screwed. You're kind of screwed. All right, so now there's other modifications that can be done to this. We're not actually going to be making those modifications. Why? In this particular case, it's not necessary. So have that back up. Make sure our fan is plugged in all the way. Drop that down in there. Worth its weight in gold, guys. Just like using Loctite, only it's easier to take apart. So we're actually going to take and we're going to put just a small amount on the screw holes, and then put our screws down in there. Now, since we know we already had a problem to start with, one of the things we're actually going to do is we're going to start these by hand. I'm not going to tighten these down all the way just yet. You'll actually be able to feel them grab. We're going to start on the back. I'm actually going to tighten these up. We're going to get the other two started. And then we'll tighten the first set that we put in. Bear in mind, these do not have to be super tight, but you do want to draw them down where they're lightly snug. That one's down. Now we'll go to the next one. We're going to do and repeat the same process and procedure on the next one. Give me a second, guys. Let's see who sent me a message. I am currently doing a live YouTube video. If you would like to join in, it's on power supplies. Okay, so we will answer his calls after we get through. The module here, the screws seem to be a little tighter, except for that one that's not even been drawn all the way down. I thought maybe we would have somebody else pop in there, since I just sent them a message. Okay. Now we've removed all the case screws and the board screws that were located in here. This is actually important, guys, to leave that plastic in these. So if it does come out, don't throw it away. Put it back. Okay. All right. Let's go ahead and start with this. Check and make sure that those are all taken care of. Now another thing too is if you get some of these that the lids rattle on. Now another thing too is if you get some of these that the lids rattle on, you can actually do one of a couple different things to take care of that. And you can actually take either a real thin film of silicone and put on the sides of this, and on the back before you actually reassemble it. And that'll help as far as reduce any kind of noise or vibration from these lids, because sometimes these will make noise, especially when the fans kick on. That's one thing that you can do. Another thing that can be done, you can actually put a piece of black electrical tape and trim it out. That'll also help, just because of the fact that it's a little buffer, so it's got something. If for some reason these are in an application where, especially if you got large fans or something that's pushing against them, you don't have to worry about these fluctuating and making any kind of a tinny, rattly noise. So that's another little tidbit. We're going to go ahead and do the same. We're going to make a dimple right next to our screw holes. These I don't think are near like the other ones are. We are going to go ahead and dimple these. Just to ensure that we don't have any noise issues. All right, so now that we got that done, set that off to the side. Clean our tip here a little bit. Pet peeve, it's not a necessity, but I am kind of resetting that one where it's kind of in there cockeyed. So we're going to try to straighten that one up just a little bit. Like I said, it's not a necessity. It's nothing that you got to be concerned about if a part's not setting in there just exactly perfect. Then we'll go back and we'll trim those excess legs off here. And getting in there just exactly perfect. Then we'll go back and we'll trim those excess legs off here in just a short. Why? Because we got to trim them off anyways on the other one. And again, we'll replace that VR adjustment. With a 10 turn. Like I said, it's just to give us a little more leniency. And when we go to do the install, it's the only reason why we do this. Oh, and we are replacing that with the same. The one was a one. These are a 1K pot, so that's what we're actually using as a 10 turn 1K. There again, it just allows us slower movement so that we can actually set these. Um, that taken care of. So we're going to add our little extra wire across here, just to give it a little extra current capabilities. And you can use bigger than 22. Like I said, if you want, you could actually use two of these. Whatever you do, though, you want to be consistent across the entire uh, set of these for whatever you're building. So bear that in mind whenever you go to do that. Like I said, you'll be surprised just what the little extra of one will do. Um, should be okay. I'm just looking to see if there's anything else out of the ordinary while we're in here before we actually go and do the actual install back into the casing itself. Once we do that, then we'll set the actual voltage adjustments themselves. So there are some of us, and I will, depending on what the job requires and what we're doing with the modules. Um, that's another interesting fact too. Now, depending on what kind of modifications you're actually doing to your power supplies, like I said, these were not going extraordinarily huge as far as on the modifications, just because of what we're going to be using this one for, which is a small power supply. Anything larger, like I said, we would go ahead and probably start stacking a little more into it as far as on the capacitance on the input side. Um, there again, the same thing applies when you use an external capacitor versus an internal. Um, your biggest thing is wherever your current draw is, the more capacitance you've got close to where your physical draw is, actually reduces the overall stress on the module itself. So that's part of the reason why you'll see some of us, and there again, it's based on what we're doing as to what modifications will get done. Like I said, I've seen people strap the fuses on them, cut out and bridge over the inrush current filters that they've got in these. You know, some of it I think is just a little too far out there because I don't like pushing things above and beyond. You know, the modules are designed for a particular purpose, and when you go overboard on the modifications, it it's really kind of senseless. All right, so now once we get this one actually installed and back together, I'll take time. We'll go ahead and set the voltage on 1 and show you how that all comes to play and works out. And then I'll come back off of camera and we'll finish up the last one of these modules. All right, get that one started. So we need to hold off on that until we actually get these screws back down into the case. That way everything's seated. Another thing, as you guys heard me talk about, if you want, you can even go so far as to take a thin coat of nail polish even whenever you go to assemble these. And put nail polish down the side. Before you do your assembly, just like that. So let's finish getting these in here, getting these tightened up. So let's finish getting these in here, getting these tightened up. Okay. All we're trying to do right now is just get our screws started, and then we'll worry about going back and getting them nice and tight. I'm just showing you a couple different ways of doing things. It's just like on this one here. Let's say you've got them started and you forgot to put the nail polish, or if you really want to get crate wild and crazy, you can use Loctite. You know, as long as that screws up a little bit, you can actually take and get some started up underneath of it. There, all it is just to help make sure or ensure that whenever those are in there, you don't have to worry about them backing out, coming loose, causing issues. Right now it looks like we're about to get a heck of a rain, so I want to try to definitely get this before we shut the computer off. When we get to a point where we can at least show the voltage being set on one of these. You know, all we're concerned about is, like I said, just getting a little bit, because this stuff is just like glue. Only it'll come apart. Get a little bit underneath there. Once it gets seated, it'll lock itself in place. All right. And like I said, for saving time, we're going to go to the next stage or step, even though we've got one more to do. Now, I love using the power cord that I've got, mainly because it's got a physical switch in it. You know, it's got the computer switch in there. For the life of me, I always forget which way is on and off, so I actually marked which way is on, physically on it, with a paint marker. So what we're going to do is we're just going to hook up our line voltage, which is going to be our black wire. That's going to go into the line. The in or neutral wire is going to be white. For those of you that have never done this. And there is actually a ground wire here. It's not going to be a necessity on this particular one, but we'll hook it up anyways for the video. All right. Now, when setting these, one of the things that I have found, if you want to get an accurate, or for accuracy, is you can take something as simple as a 300 ohm resistor, a specific light bulb, anything that has just a small current draw or will allow for a small current draw. You can actually take trim the ears off of this. And whenever I'm setting these, I usually use the same resistor from start to finish. And oftentimes all you got to do is just push it in there and allow it just to make contact and kind of halfway hold. Just going to hook up the negative right now. Plug our module in. Turn our switch on. Okay. Then we're going to do a preset on our voltage. And on these, like I said, we're going to set this at, I think the customer said he wanted it at 14.8. set at 14.800, which is what we had. Just utilizing our little 10-turn pot. Like I said, we do have a 300 ohm resistor that we're using for a load resistor. You know, it is going to get a little warm, but not so hot that you can't still touch it. You know, and that is just to allow us to go ahead and make sure that, you know, under a minor load, that we're actually set properly on our voltage. And you've seen it before. I pulled that out. Okay, now we're at 14.79, 17.98, you might as well say 7.8. Kind of keeps fluctuating there just a little bit. And that's to take care of that offset, because usually when you go 2 and 3 places out, you'll actually have just a slight change, and that's what we're trying to make sure that we don't have. Is we want to take out for deviations in it, or floating voltages. Once these are actually all put in line, typically there's a fan or lights or something that always hooked to these, so there's always a slight current draw on these at all times. Once you turn these on to activate them, whether they're in a power supply unit themselves or what have you, it's just a minute amount of current that you want to actually be able to draw on these, and that way you know that you have a stable reading across each one of these units as you're building them and putting them together. That way there's no influx from module to module. They're all the same. So guys, I appreciate it. I hope that has given you a little bit of insight. Like I said, I've got one more module. We're going to go ahead and put down what we've got these set at. That's another important thing too, that I like to do, is right on the corner of the case, on the top, someplace on it, what the voltage is actually set at. And like I said, whether you're using the same light bulb or what have you, just put some kind of a minute load on it. Like I said, it doesn't have to be much more than 30 or 40 milliamps of current draw. An LED with a resistor on it works just the same way. So it's whatever you have, you can actually utilize, and just stay with that same configuration, that same specific piece from module to module as you're setting these whenever you go to daisy chain these together in a parallel format for higher amperage. Guys, I hope this has helped a little bit as far as on a little bit more info and insight. Like I said, just trying to give you a little bit of heads up, a little bit of info. I've got other videos that I'd like to do as far as on technology and showing you as far as with coax and what have you, but we've got to really get some of these repairs caught up, and then we'll go back and try to do a little bit more as far as for information videos to help you out. Folks, we appreciate it. Thanks for watching. For information videos to help you out. Folks, we appreciate it. Thanks for watching.